Good morning, students. Myself, Dr.BADI ALEKHYA, Assistant Professor, Department of Artificial Intelligence and Machine Learning, R.M.D. Engineering College. Today, we are going to discuss the important concept in deep learning, backpropagation. Backpropagation is a foundational algorithm for training artificial neural networks. So, what is the purpose of backpropagation algorithm in deep learning means once you pass the input from the input layer and then to the hidden layer and then to the output layer, we are going to predict that our network is accurately predicting the output based on the user needs. If it is not accurately predicted the results based on the user needs, we are going to allow the networks by adjusting their weights and bias to make the networks to calculate the accurate predictions. This is the purpose of backpropagation. Now we understand what's the problem statement, why we are moving, what are the things we have to consider when we are applying the technique of backpropagation. So when and where we are using backpropagation means we have a data with complexity, and we are going to handle that complex data relationships when compared to traditional algorithm. There we are in need of backpropagation. Learning from data, how then when we are going to train any model in a neural networks, we have to train the model with patterns and relationships that after training the model with patterns and relationships, the model can ready to predict the new and unseen data also. Error minimization, when we are going to predict the output at the output layer, the predicted output calculation must be near to the actual value. We are going to, if it is not near to the uh, actual value, we are going to minimize that things by considering gradient concepts. So what is gradient discussed? Already we discussed in the third point, to minimization of error. We are following one technique under gradient descents. That gradient descents will rely on back propagation to updates the weights and bias, navigating towards the parameter configurations. So this is the things we have to understand the problem statement scenario before going to apply your back propagation technique. So what is, in which way the neural network architecture will be framed means input layer, hidden layer and output layer. Input layer will receiving the raw data that will representing the features of our data set, and hidden layers will process that input data and also perform some complex computations and future transformations based on activation functions. And output from the hidden layer we are going to pass to the output from the hidden layers are going to pass to the output layers, which will be useful to produce predictions based on the processed input data. And we will see how back propagation algorithm will works. Here in the forward pass, between the forward pass and the backward pass, we need to calculate error. Based on the error gradient only, we are going to proceed with the step of backward pass. First we calculate forward pass. In forward pass, what we are going to do means we are going to pass the data from the input layer to the output layer. After out after passing to the output layer, the output layer will predict the output. Then that predicted output we are going to compare with the actual output by error calculation. If there is difference is measured, if the difference is more means we are going to move to the technique called backward pass. Here the backward pass will having the knowledge of error signals propagating backwards. How it is going to rectify that error means by adjusting the weights and bias. Here what are the equations derivations we are going to use and applied in our back propagation processes. One is error function, second one is gradient descent, and third one is chain rule. Here error function measures differences between predicted and actual outputs. After predicting the error between the predicted and the actual output, it's calculating the gradient of the error functions to update the weights and bias. For example, if we are going to find out there is a difference between our actual output and the predicted output, based on that we are going to update our weights and bias in the gradient descent by applying gradient descent algorithm. So where and which node? For example, if your error is occurred in one part of the network, it is going to update by applying the multiple derivative concepts across that particular node of the layer by applying the chain rule. How here we have discussed everything after calculating the output. If the output predicted output is not equal to the actual output, we are going to adjusting the weights and bias by using the gradient descent. How that weights and bias are initialized means by three techniques: random initialization, bias initialization, and weight initialization. Under random initializations, we are going to apply the weights and bias to prevent symmetry, and bias initialization we initially set the values to 0 and then for the small random numbers. Under weight initialization we have some techniques like Javier distribution technique based on activation functions. In this way we are going to initialize the weights and bias. The main purpose of this backpropagation technique is to minimize the loss function in the network what we pass from the input to the output layer, and reduces the difference between the actual and the predicted output. How the forward propagation and error calculations? The steps is, first it is receiving the data from the input layer and then it passed to the first hidden layer. The first hidden layers are converting the data, transform the data through calculations and activation functions. After processing the data from the hidden layers, it is going to pass to the output layer. Here in the output layer only we are performing predictions, then only we are performing error calculations. Here we are going to calculate the difference between the predicted and the actual output. After it is forward propagation steps, then after calculating the error we are going to move for the back propagation. Under back propagation, based on the error calculated between the difference of actual and predicted output, we are going to adjusting the weights and bias based on this error function. And then at which node we have to identify the error function rate will be more. On that particular node we are going to adjusting the weights and bias based on the derivatives by applying the chain rule concept. So how we are going to update the weights and bias? Based on learning rate, gradient descent and optimization techniques. When we are going to initialize that things directly, we are not going to include that weights and bias in the networks. We are based on step size and gradient parameters. That means we should be very careful when we are selecting the weights and bias. It should not makes the networks to move into the negative gradient, and also we are considering momentum adaptive learning rates to make the networks to work in a optimized manner and produce accurate results. So the problems for this back propagation techniques already available in our YouTube channel. Please refer that for calculation of back propagation techniques in a mathematical way. That's all students for the today video. We will meet with some other new concepts in the next video. Thank you all.